And so let's just sort of get into it, walk through it. Well, just as an overview, California and San Diego are knowledge-based economies. And anything that's not knowledge-intensive or knowledge-based, I think in this area is going to be subject to great cost pressures. I want to just show you a few slides about California. This is California's share of USPTO patents, right? And what you can see is the foreign share since 1963, the foreign share of US patents has been growing. It's been a secular growth. More and more patents are patented in the United States by foreign companies. A state that is different from the rest is California, and that's in yellow. And what you can see is California is taking a greater and greater percentage share of USPTO patents. So it's swimming against the tide, against the rest of the US states. Massachusetts has been growing, but it's a very small number. And Massachusetts patents have been growing slower than California patents. So this tells you something about the way California is competing in the global economy. If I broke that down, the Bay Area would be the most, but San Diego, as I think Mary will show, is also growing its share of US patents. So there's two areas of California in particular are growing their share of US patents. Global top 50 universities, 10 of the Shanghai Jiaotong top 50 are in California. 5 are in the UK, right? That's a country, right, compared to this state. 4 are in the state of New York. In other words, New York's no comparison. New York's share of patents has also been decreasing. So the California economy is quite unique in a number of ways. Venture capital disbursements, we all know this. Red is Silicon Valley. 35 to 40% of all venture capital that's invested in the United States since 1980 has been California. This is not inflation adjusted. The red is California. It's invariably, the red is Silicon Valley. SoCal has been going up. So if you look at SoCal over the last 30 years, SoCal's share of venture capital has been going up, though it's more oscillating. Sometimes LA is up. I think right now LA is up and San Diego's down. Other times maybe San Diego's up and LA's down. Together they'll take about 10% of all venture capital investments. Boston will be 10%. New York will be the 10 to 15%. But you can see California is so overwhelming. Almost 50% of all venture capital invested in the United States is in California. That's about 25 to 30% of all venture capital invested in the world is in our state. So how do the universities influence knowledge-based growth? Okay, so here I'm going to sort of talk about what others have written and try to explain how our book is quite different because of the perspective we take. The public policy focus in technology transfer has been around patenting, the Bayh-Dole Act, patenting and licensing. People have focused on that as the big way that technology transfer gets done. Our book shows that that is a very narrow perspective. There's a large literature, economics and innovation studies, and the empirical work is always focusing on the countable, what's easily countable, patents, licenses, and startups. Right? I mean, we've all done that work. I do that work. But we have to understand that that's a very narrow focus. Most of the case studies have been focused on MIT and Stanford. Right? I mean, it's as though the privates are the only ones that are doing technology transfer. So this book, I think, is an important contribution to the literature because we look at the best public university system in the United States, the University of California, and look at how technology transfer is happening in the UCs. Okay, so these are case studies. They go beyond just patenting and licensing. They're focused on a public research university. We look at multiple academic disciplines. Most of the research has been on biotechnology. I mean, probably 75% of all tech transfer research is on biotech. The other 20% would be on the IT, information technology, software, etc. And 5% is the rest of the disciplines. So Each study is historical and traces the evolution and the interaction over lengthy periods of time. What we show is that technology transfer is not a one-off, but it's a set of relationships between the university, and not just the university, but really a lab, a department, a professor. So we look at the micro level. We look at wine, right? Nobody has actually looked at the wine industry. You've heard of Napa Valley. Napa Valley is a knowledge-based industry, right? $4.5 billion a year of wine and another $1.5 billion in tourism for a very small place. It's a knowledge-based industry. And the relationship between UC Davis, we won't talk about that today, is one of those relationships. Another one we look at is scientific instruments in UC Santa Barbara. Scientific instruments are nice businesses that spin out of universities. Okay? Not nobody. Cyrus Modi, who contributed a chapter to this book, has written about that, but very few people have looked at scientific instruments as a business opportunity that universities help create. So, the book has some limitations. It's opportunistic. Not all UC campuses are included. Only a few fields. We have biotech, we have wireless with Mary, biotech with Steve, we did scientific instruments, we did wine, we did semiconductors, but these aren't all the fields. Right? Statistics, nobody thinks about statistics spin-offs. There's a company called SAS in North Carolina, has 10,000 people. Came right out of a statistics department. Right? So we don't think about all these other ones. We look only at significant regional industries. The Bay Area, information technology and biotech. Napa and wine. San Diego, information technology, specifically wireless, which Mary did, and biotech again. Santa Barbara, scientific instruments and nanotechnology. That's a real center. It's a global center for that type of activity. What we show in these chapters is that very, very often, most of the time perhaps, technology transfer is not a one-way street with knowledge and people just flowing from the university to industry, but actually it's a two-way street. And very often it's a two-way interaction. Not all the time, but very often, where knowledge and people flow in both directions. And where cutting-edge industry problems, here I think about semiconductors. The semiconductor industry, surface science, is so sophisticated that it develops problems for industry. For industry develops problems for the university. Sorry, wrong way. So, and what we show is that in many of these cases, the boundaries between industry and university are very porous. And that's how knowledge flows. And this porousness is valuable. Finally, we show, these chapters show, that there are multiple reinforcing channels of interaction. People, knowledge, things, little things moving back and forth, or pieces of equipment moving back and forth are what create these energetic university-industry collaborations. Okay, so what are some other themes? Development was often affected by large research-intensive universities firms located near the campus. So Qualcomm is a research-intensive firm, as Mary will point out, and it has interacted with UC San Diego, but it isn't the only one. Fairchild and Intel in Silicon Valley with UC Berkeley. Stanford also, but we're looking at the public's UC Berkeley. Some of these firms may even have been university spin-offs that grew quite large. The Qualcomm example, Digital Instruments in Santa Barbara, Genentech in the Bay Area. So there are many of these. And that the relationship between regional industry and academic research changes over time. They co-evolve together. So it isn't, you can't take a one picture, but you have to see these as evolving relationships. When it's healthy, it's an evolving, growing relationship. And the role of the university and the firm or the regional industry changes over time, and what the university does to help the regional industry changes over time. The academic research that we look at very often is a mix of fundamental and applied research, and it's even hard to tell which is fundamental and which is applied. Federal research funding and infrastructure was the foundation for the links between industry and academia. That's true in the case of wine. That's true in the case of wireless. That's true in the case of biotech. In each case, it was a different part of the federal government. USDA with wine, the Department of Defense with wireless, and NIH with biotech. But the federal government was a key player in all of this. So those are some of the themes. The economic benefits flow. We find that the economic benefits flow from the core UC missions, research and teaching. Right? The research is very important, the teaching, because we show in almost all of these case studies the flow of graduate students, of trained people into the local ecosystem that the firms take advantage of. The economic importance of the research and training dwarfs all formal transfer activities. The formal transfer activities in the Technology Transfer Office are minuscule compared to the economic importance of the research and training. The net institutional income from licensing is far outweighed by sponsored research and philanthropy. Mary will talk about the philanthropy of Irwin Jacobs here. That's probably more than your tech licensing office has earned in its whole time of being in existence. That's how big philanthropy can be. The patent value, which many people study, varies greatly within and among research fields. So in IT, generally, not always, patent value is relatively low. In the biotech, it can be quite high. And patent licensing and evaluation metrics need to understand this reality of the true value of patents. And then in two of the cases, Mary will speak about one, but the other case in the book, the wine business, the role of university extension is actually way underappreciated. I mean, for the case of Napa, Davis is university extension, not ag extension, partly agricultural extension, but the university extension office in training and retraining and upgrading the winemakers and also the owners of wineries who need to understand the economics of owning a wine was a very important value add to the creation of the Napa cluster. Okay, so in conclusion, patenting and licensing can only be a complement to university research and training missions. These are the core missions. Each one of the chapters shows that that was the core mission, far more than tech licensing and patenting. Okay, so that's one. The key challenge then is to manage patenting and licensing to support these core missions, the core mission of technology transfer, of training and research. And the management to support interactions and understanding the greater social good. So open source software, Berkeley Unix, SPICE, which is a semiconductor design software, were freely given. They weren't patented, they weren't licensed, they were just entered into the public domain. And we show in the chapters how important that was for the development of the local industries. Here we're talking more about the Silicon Valley area, but the same in Napa. The research at UC Davis in wine was not patented or was not licensed, and some of it could have been. It was just given to the industry and was very valuable to the industry. So we have two presenters who are going to present their chapters in the book. We have Mary Walshok, who will talk about, her title of her chapter, Serendipity and Symbiosis, UC San Diego and the Local Wireless Industry. And we have Steve Casper, who will speak on the University of California and the evolution of the biotech industries in San Diego and the San Francisco Bay Area. He's tweaked his presentation a little bit to give you a little more of some of his other work, but it will be basically, that will be the basis of his work. So, let me introduce Mary. One slide per person. It's very difficult for both of these distinguished people, but one slide because we want to hear them, and well, we would like to hear about their accomplishments, but we have to keep to a time schedule here. Without her encouragement and support, this book would never have happened. Mary was key with Dave Mowry. She encouraged us, helped us find financial support for the effort, and at all times was just a great mentor and collaborator. It's impossible to summarize Mary's accomplishments in one slide, so I'm going to try. She's the Associate Vice Chancellor for Public Programs and Dean of Extension. She's the author of numerous books. There's a flyer over there that you can pick up on the way out. Invention and Reinvention, The Evolution of San Diego's Entrepreneurial Economy. Really a great book. Author of 100 articles, and probably the best summary is everybody everywhere knows Mary, and UCSD has great fortune to have her here. Literally, you go to Sweden, you go to Finland, you say, oh, I know Mary Walshok, and they buy you a beer. Or, well, maybe not, but anyway, they know her, right? She's worth a free beer almost anywhere. So, that's Mary. Steve has a PhD in government from Cornell. He's the interim dean of the School of Applied Life Sciences and Henry Riggs Professor of Management at the Keck Graduate Institute. Previously, he was a university lecturer in innovation entrepreneurship at Cambridge, and 2009 was a Fulbright Scholar in Canada. In 2007, he published an Oxford University Press book on Europe's efforts to create Silicon Valleys. I'm not sure how successful they were, but maybe we can ask him at the end. He's published extensively on university-industry relationships in biotech, and lately has examined the differences between the BT and biotech industry at different parts of California. Literally, he has the best database on management, patents, entrepreneurship in the California biotech industry. Perhaps it's the best database, granularity of any database on anywhere in the world on the biotech industry, or maybe any industry. When we got this project going, there was absolutely no doubt we had to have Steve involved, and thankfully he agreed to join us. So with that, I will thank you and turn it over to Mary. And there's water here if you need it.
And I see a couple faces I recognize, and I appreciate your being here because I think it'll make for good conversation, particularly, Guy, after you hear Steve's talk, which is very, very interesting and stimulating in terms of the differences in how the life sciences evolved in Northern California and Southern California. But what I'm going to do just briefly, and for those of you who arrived late, this conversation and these presentations in our conversation are being recorded for the library archives, because the UCSD library has an archive both in science, and they're building one in technology. So stories about and interviews with people who have been a part of the growth of those two sectors in this region are an important part of our commitments as a library. When we decided collectively that I was going to try to write the piece on the wireless industry in San Diego, it was just at about the time, I can't remember if it was Fortune or Forbes, identified us as sort of the wireless center of the world, right? Finland and Sweden might want to argue with that, but certainly of the United States. And I started a conversation with Martin because I had been working with an historian who got his PhD here, and we'd been looking at a lot of early San Diego history, and particularly military history, and uncovered a lot of information about radio towers and communications research as early as 1917, 1920, long before there was a University of California campus here, 50 years before. And so we began weaving a narrative for a book which eventually became this book on San Diego's evolution, which Stanford University Press published, about the path dependency, if you will, that comes from early industries that over time shape both regional economies and the regional universities that serve those economies. I'm not going to spend a lot of time on the early history, but again, because I see 2 or 3 familiar faces in the room, I'm going to say for the record, Qualcomm was not a UCSD spinout. UCSD takes enormous credit for the entire wireless industry in San Diego. And when my colleagues Nathan Owens and Josh Shapiro and I started looking at the actual patenting, licensing, and spin-out data, the numbers were less than the fingers on my 2 hands. It's a different story. Qualcomm clearly is connected to UCSD, but in ways that are very different, as Martin was suggesting, you would think, based on our tendency to count patents, licenses, and spin-out companies. Just to remind some of the younger people who are here, Irwin Jacobs came to the UC San Diego campus in the early 60s. He was only here for 5 years. He took a year's leave of absence to build a company called Linkabit and never returned. He founded Qualcomm 14 years after Linkabit was founded. So he had been a business person for 14 years. On the other hand, he had some interesting challenges in both Linkabit and Qualcomm, which we realized were the clue to the value of a research university in this sector. And that was archives that I listened to from the library. We learned very early that he had a terrible time attracting engineers to come and work for these companies. There were so many more jobs in the Silicon Valley, and at that time even in the Los Angeles area. And if you think about engineers in the 1970s and 1980s, your tendency was to go to an area where there were lots of engineering jobs, right? So if the company you were working for or the contract you were working on ended or didn't succeed, you could find another job somewhere else. And so there were areas of the country with much better reputations. And so one of the biggest challenges in the early days, and they spent a lot of time and money, and Irwin personally, going to Boston, going to Maryland, going to Purdue, recruiting engineers to come here. And this storyline became the core of our chapter, because what the data that we found suggests that UCSD was an extraordinary resource and partner, particularly to Qualcomm as a company, introducing a new technology platform, CDMA, for which engineers needed to be especially trained because it wasn't the dominant platform at the time Qualcomm started. And between the School of Engineering and Extension, thousands of young engineers came through UCSD to get master's degrees, certificate programs, and PhDs that qualified them to work in the wireless cluster. So that's kind of the big story in our chapter. Just to refresh your memory, there are a few people with white hair in the room who will remember this history. But when the UC San Diego campus was started, we were in the midst of the Cold War in this country. And there had been a long history at the Scripps Institution of Oceanography, as well as among many defense contracting firms in the region, of doing research and development for the military, for the Department of Defense, for the Department of Energy, most of it related to national security and the advanced technology needs of these industries. Many of the first professors who were recruited here had worked on very big projects before World War II and after, and big labs at Princeton, at Chicago, at MIT, and it just happened, they weren't even friends at the time, that both Irwin Jacobs and Andrew Viterbi, who were two of the founders of both Linkabit and Qualcomm, had done summer postdoctoral fellows at the Jet Propulsion Lab near Caltech in Pasadena. So when you look at the profile of many of the early faculty, most of them had some kind of experience on research projects or with research funding or in postdocs that involved this kind of research. That's where the money was in the post-war era, as NSF and NIH were growing, and you'll hear some of that from Steven in the San Diego context because of the role of the Scripps Institution of Oceanography in World War II, as well as the companies that were here. The UCSD campus had this cast to it. In the book that Abe Schrag and I wrote, Abe came up with the term, and actually it comes from Lochin, that San Diego was a military metropolis. And a military metropolis, we were able to document, it was based on the percentage of GDP that was related to military bases and defense contracting, but also, as many people have now forgotten, in 1940, two things happened that were very important in San Diego. One is FDR, I think I've got my dates right, declared us one of America's federal cities, essential to the war effort in Europe and Asia. What did this mean? Federal money came in not just for defense, but for infrastructure, for water, for roads, for housing, for schools, to support the labor force that was building up here to participate in the war effort. The other thing that happened in the University of California system was Robert Gordon Sproul, then president, identified two locations for the University of California's Division of War Research. And that's what it was called. And Scripps Institution of Oceanography was designated the university's Center for War Research in Southern California, not UCLA or other campuses that were already existing. And in the Bay Area, it was Berkeley and Livermore, I think there was a connection there. And we have a quote in the book that the president of the university, given what was happening in the world in the late 1930s, made the statement that there is no more noble purpose to which the research of the University of California can be put than to the defense of democracy in the world. I share all of this with you because these are important values and purposes that shaped the founding of this campus and relate directly to the final sort of historical point I want to make, and then I'll tell you about wireless, and that shaped the strategy of all the institutions on the Torrey Pines Mesa, which in the post-war era saw themselves, we were dedicated to doing basic research in the national interest, and to do that kind of research, they needed the best and the brightest from anywhere in the world. And so the UC San Diego campus did not recruit assistant professors fresh out of graduate school. They recruited, the early faculty were senior faculty from campuses like Princeton and MIT and Caltech and Berkeley, who came in their 40s, some of them in their 60s, near forced retirement on other campuses, and brought with them their connections, their research grants, their graduate students, and their funding from mostly federal agencies. So Salk, UCSD, General Atomics, all these institutions you see on the Torrey Pines Mesa very, very quickly became world-class research institutions. And it's a very important part of our history, largely fueled by the growth in federal funding and the regional strategy to attract the best and the brightest. The final point that historically is important is that San Diego as a city had a long history of land use strategies to attract clean and high-tech industries. The military was defined in the 20s as a clean industry. And if you think about what the industrial world looked like and what it was like to live in Detroit or Cincinnati at the turn of the last century and well into the 1920s, they were pretty dirty cities and grimy places to live and work because of the nature of the industrial activity. And many of the early settlers who came here, and again, the virtue of doing a book with an historian is you start reading letters and journals you never thought you'd take a look at, and you discover that many of the Scripps family members wrote letters home about how relieved they were to be in a clean and pristine environment, free of the ravages of the industrial Midwest, and that they would never return to, that kind of a life. And so you have a history in San Diego of people wanting to build an economy based on clean industries, seeing the military as a trajectory for economic growth, and as the military, particularly naval and aviation, think communications and remote signal processing. How do we talk to ships? How do we unscramble messages from German U-boats? All of that kind of research and development was going on here long before there was a University of California. So if you were antagonistic to the University of California, you would say, well, we think we're so important, but it wouldn't have happened without the city. Let's stop tooting our own horn. But part of the reason we titled this chapter, and actually it was Martin's suggestion, Serendipity and Symbiosis, is because one of the early recruits to this campus by a superstar scientist from MIT was Irwin Jacobs. And he came as an associate professor, and he came in 63, 64, but when the campus was very young. But he came with a family, and he had the opportunity to do consulting, and so he took advantage of the 1 day a week that professors get and started consulting with the military on what in those days was called remote signal processing, which is how can you do communicate with ships and airplanes and across long distances in clear and secure ways. And out of that came the creation of Linkabit, because he and two other professors, one at UCLA and one at USC, Andrew Viterbi, were working in the same technology space and collaborated in doing research, applied research, contract research for the military. The opportunities became so great that they decided they needed to start a company. So no longer being the 1 day a week consultants, they needed to start a company. And Irwin agreed to be the manager of that company and to run it. Otherwise, all the story that I'm going to tell you in the next 5 to 7 minutes might have happened in Los Angeles. And that's why we say serendipity. Andrew Viterbi was at USC. Leonard Kleinrock was at UCLA, and they were sort of the leaders of the technology platform developments. But Irwin had spent a year at Cornell in the hotel and restaurant management school because his father had been in the restaurant business, and he thought he would go into the family business. But he fell in love with engineering, called his dad, hardest phone call he ever made, said, I don't want to go into the family business, I want to go into engineering. And so he volunteered with his 3 colleagues, and we have this in an interview that my co-author did with Irwin. So he volunteered, well, I guess I can manage the company. I had a year of management education. So the company was located here. And that company, as you can see from this chart, is basically the grandfather of the major wireless companies that then developed in the region. That company was not a spin-out of UCSD. It was a creation of professors from 3 different universities. It was a consulting company that was developing communications platforms that would be more effective, in particular for the Navy. That company, within 7, I can't remember if it was 7 or 8 years, was acquired by a Boston company called Maycom for about $40 million, a lot of money then. Guy and I now share history, right? And a lot of people got very rich. And I have interviewed, in fact, with Nathan, we had a wonderful interview with Harvey White, who was one of the members of that company, who then went on to found Qualcomm, and Irwin, and Andy Viterbi. I've had some conversations, which I'm now going to turn into a real interview. And I just want to share this story more for the record than just for the audience. What we were told, Nathan, correct me if I misrepresent it, is, well, you know, the 7 guys, and at that time it was guys, who had built Linkabit and cashed out, would get together for coffee at the Panican or someplace in La Jolla once a week. And eventually Irwin left the company that acquired his company. It always happens, right? They give you a little time to think you're really running things, and then you discover they don't want you there. And so we were all retired, and we were all bored. We were too young. And we sat around and said, what are we doing? Let's start a company. And what Harvey said to us, we had no market, no business plan, but we felt we had a killer technology. And what we needed to do was to work together to find a business and an application of that quality communications technology. And that became Qualcomm. And so if anybody deserves credit for starting Qualcomm, it's probably the Panican in La Jolla, as opposed to the UC San Diego campus. Now, I've taken about 10 minutes to give you this sense of context, because it's in that context that I call my friend Martin and say, oh my God, I don't think there's a great story here. And we start talking, and he said, oh, there has to be, because we know that Qualcomm, we know it's an anchor institution. And we know the contemporary synergies that exist between Qualcomm and the UCSD campus, and increasingly the SDSU and other campuses. And I found myself, I think I said, yeah, you know, there was a period there when Extension was training engineers. We were asked by Qualcomm as an extension service. They were recruiting engineers from all over the country. But none of these engineers had been introduced to the CDMA platform. I don't know how many of you know, but Qualcomm 25 years ago had an industry-challenging platform. okay? So the accepted platform was something called TDMA. I'm a sociologist, so don't ask me to tell you much more about the engineering. But that's what Motorola used, that's what the phone companies used, that's what the military used in all forms of wireless communications. And this group of guys, Qualcomm, felt CDMA was a superior platform, and they were out to prove that it could work. And so that was what they began with, and then they found a market, and the rest is history, as they say. But what I decided to do after talking with Martin and a couple of other colleagues was to get some help looking at graduate degrees, masters and PhDs awarded starting in the 1990s when Qualcomm began to really focus on developing multiple apps using the CDMA platform. And it happened to coincide with the launch in university extension of a series of courses and certificate programs tailored to the wireless industry, taught by many of the engineers working at Qualcomm. And the numbers were impressive. So today, just to reinforce Martin's notion, something important happened here related to Qualcomm, and you can see 3,000 IT, wireless, and software companies. And you can see how they cluster, particularly around UCSD, these notions of symbiosis. But here's what's interesting. We literally had to do this manually. But what we discovered is the growth in the same year that Qualcomm, I think, was founded in '85, but they did not commit to focusing on CDMA as a core platform until the early 90s. And so that's why we chose the early 90s. And you can see the growth annually in master's degrees and PhDs related to the industry. In other words, symbiotically, the engineering programs at UCSD began to be a place to develop the talent that the regional wireless industry, initially Qualcomm, but eventually the whole cluster of companies needed. The other piece were the UCSD extension certificate programs. And we identified close to 1,800, I'm not sure they're all individuals, but primarily individuals who went through different programs in different years related to the wireless industry. And so this sort of coincidental or symbiotic growth in new curriculum and new graduates in both the graduate school and in the extension school, which provides primarily certificates to post-baccalaureate adults, suggested quite a bit of symbiosis in these relationships. Now, what I have not put in my slides, but what is in our chapter, if you buy the book and read it, is a further discussion not only of the synergies and talent, but the important co-investments that were made from the late 1990s onward in joint research programs. So people who know the San Diego campus know we have the Center for Wireless Communications. And then we created Cal IT2, which is now the Qualcomm Institute. But we were able, as a campus, to raise over $200 million in matching funds for a $100 million investment from the state of California to create a major center of interdisciplinary research in wireless applications, IT and communications. The other piece that I didn't provide a slide for today that Martin alluded to is the growth in philanthropy. So as many of you know, even though Irwin was here for only 5 years, even though he didn't spin his companies out of here, and even though there are a handful of companies that did spin out, but of former students who spun out companies, but they spun them out of Linkabit, not out of UCSD. Do you understand what I'm getting at? So we have some UCSD students, PhD students, who've started companies, but they didn't start them out of UCSD. They started them out of Linkabit. Nonetheless, the Jacobs family has contributed, I think it was $110 million to the School of Engineering. They've endowed chairs in the Graduate School of International Relations and Pacific Studies. They've been extraordinary contributors. And Qualcomm, the company, has been a partner in research programs inside the School of Engineering. So clearly, the relationship between UCSD and the wireless cluster fits the characterization that was provided by my friend Martin. It's reciprocal, it's evolutionary, and it's mutually beneficial. And we think it's an interesting story. Okay. Stephen, you get to. Or do you want to do any questions? Any questions or comments right now? Sorry if I ran over a little bit. Okay. Stephen, your story.
All right, so let me get this going. There we go. So first I want to thank, it's the power of my, I was just going to say thank you to Mary for all the work all the help over the years. A lot of this stuff on San Diego, I'm going to show you. Some of the original data I was using comes from UCSD Connect, and I've pillaged a lot of Mary's files over the years. I really want to thank her for her support. And then Martin I've known since I was a graduate student, and I've always just been immensely, just encouraged by his work and his approach, which is very empirical, problem-oriented, very global. And, I haven't really been able to mimic that, but he's just been incredible as a kind of a mentor and somebody to really try to follow in terms of his approach to finding interesting problems with the global economy and having unique kind of economic sociology approaches of looking at them. So what I'm going to do today is I've done 2 projects over the years on California biotechnology. I had a big project from around 2004 to about 2010 when I was really focusing on the issue of how do technology clusters emerge and become sustainable. And that research focused a lot on the comparison of 3 areas of California, San Diego and San Francisco, which are sort of seen as success cases. And I'll even put a slide up here. And if you look at this, two of the big 3 clusters in the world are in these regions. And I was looking at my home, my own home area, Los Angeles, as sort of my failure case, which is a surprising case because they've got world-class universities too, and they've got one of the big 3 biotech companies in the world, Amgen, is there. So I was looking at that as my kind of failure case. So what I'm going to do is provide a little bit of data on that just to kind of show how these clusters grew. The approach I've been using comes again from this field of economic sociology, and there are, truth be told, numerous factors that impact how technology clusters emerge. And Martin's work on Silicon Valley has been one of the most important guides of that, looking at the infrastructure of entrepreneurial regions and how they develop. I drew very strongly on research coming from Woody Powell and Annalise Saxenian, looking at the role of social networks within clusters. And I'll show you a little bit of the data I collected, trying to kind of substantiate whether there are differences in how social networks linking senior managers and then also looking at scientists developed in these regions. And then more recently, the last 4 or 5 years, I've been focusing a lot on the commercialization of science. My current job is at the Keck Graduate Institute, which is a kind of a unique professional school in the Claremont colleges that's focused on translational science and the biosciences. It's a professional school. So I've spent a lot of time working with actual natural scientists that are involved in commercialization, and I've got to learn a lot about that field. And that led me to really look a lot at the role of universities in the origin of these clusters. And the chapter I helped write for the book with Martin and David really focuses very much on how the origins of the two clusters linked into UC San Francisco and UCSD, and how different relationships between early companies, Genentech up in San Francisco and a company called Hybridtech, which a lot of you probably heard of down here in San Diego, led to different sort of imprinting processes of the cluster. So I'm going to show you a little bit of data from both those things. I put a lot of slides up because I wasn't sure how long I had to talk, so I'll go through some of them quickly, but I have a bunch of cards. If you want to see the whole slideshow or papers on this, email me, and I'm an academic. I'm happy to send them out. So I'll go through some of this, then I'll finish up with some conclusions. So again, if you look at the California bioscience industry, and I've been focusing a lot on the first 20, 25, 30 years of the industry. So this is data from 1972 up through 2005, 2006. Again, you have this big difference in the relative success of these clusters, where you have very large clusters. These are kind of entrepreneurial venture-backed companies in the three regions. You just have many, many more of them in San Francisco and San Diego, as opposed to Los Angeles. If you look at things like IPOs and exits, also very different. Again, one of the approaches that's really popular in the literature, I like it because it has very kind of strong micro-level kind of, or behavioral sort of, a behavioral approach to understanding why people behave and why firms behave differently in different regional agglomerations. I use very much research by Saxony and Almeida and Kogut, Lee Fleming, Powell and so forth, looking at social networks. Just very briefly, the idea there is that social networks linking companies provide companies in those networks with an information advantage in terms of people knowing each other and talking and having beer and whatever it is, being able to get information about what's going on in these clusters. And these firms also tend to have more of an external R&D strategy, which today resonates very strongly with the kind of open innovation agenda promoted by Chesborough and so forth. Moreover, and this is what I've looked at a lot in the work I've done, I've always wondered, what does it take somebody like Aaron Jacobs, to leave a place like UCSD and go work at an entrepreneurial firm, knowing that most of these entrepreneurial firms don't do very well at the end. And the kind of social network approach is, well, if you're in a big agglomeration and you know people at 20, 30 other companies, if you go leave a safe job for a risky job, you can basically get another job if things go belly up. So there's a career mobility kind of labor market flexibility argument coming out of this literature. And this helps companies because it's easier for companies to take strategies where they can let go of labor or hire labor very quickly, or skilled labor, because again, you have these very large active labor market. So I've been trying to document that more than anything else. I'll just go to some of these slides. So I've been trying to develop career affiliation networks through a database, trying to figure out all the senior managers that work in a database I collected of biotechnology companies in these three regions. So I'll just show you some of these slides, just they're fun to look at. I won't go through any of this. I can show you later if you have questions. So this is San Diego. This is their career affiliation network of senior managers working in the biotechnology industry in 2005. And there's a lot I can talk about how these are constructed, but basically the dots are senior managers, and the lines between them mean they know somebody else because they worked with that other person on the senior management team of a company. And there's an assumption within the last 5 years, so these aren't agglomerate. If you don't renew these ties, they kind of fade away. And the takeaway here is there's a big, rich, dense social network in San Diego biotech that I think, for numerous reasons, really helps explain the vibrancy of this cluster. This is San Francisco. It's the same thing. It's just a little bit bigger. The orange dots, the red dots are all Genentech, and the orange dots are people that used to work at Genentech. And again, you have this. There's so many ties there, they just appear as black. Here's the kind of failure case. This is Los Angeles, this is where I'm from. And so I had a grant, I've had 2 or 3 grants, trying to explain to the city of Los Angeles how they can fix this. And it's a really hard public policy problem. But I think it's fairly convincing that part of the problem in Los Angeles is that you don't have that social mobility of people moving from firm to firm, or more than anything else, leaving Amgen to start other companies. This has changed a lot since 2005, 2006. In that they've had 2 big changes of management of Amgen, and they're now much more kind of biotech industry-like in their willingness to basically hire and fire at Amgen. So the whole senior management crowd at Amgen is either retired or started other companies in the area. So this is really helping this area. But again, the contrast is just what we're after here. It's just this huge contrast. Here's just one slide I put in. We asked, so how many people do you know in San Diego for different years at different degrees of separation. So how many, so if you look at that middle band, people in San Diego by 2005, most of the managers knew people at like 30 other companies, which is impressive. And that's the idea that that's where that vibrancy comes from. You, in theory, can get information from those 30 other companies, or more likely can get opportunities for jobs and so forth. So some of the other research we've been trying to do on this is actually trying to understand where the founder teams for these companies come from and how network connected are they, and so forth. And you see that's the case. So you see now that these social networks, they seem to exist. How do they emerge? So that's the thing that I think is the really interesting question. How do they emerge, and are there implications of the process by which they emerge that impacts the characteristics of these clusters? So I'm just going to talk about San Diego, and I'll make some allusions to San Francisco, which is also super interesting, but I'm here in San Diego, so I bet you want to hear about San Diego, and I really want to hear if I'm wrong, since you guys are obviously part and parcel of the community here. I want to argue that in San Diego, and this is very, very similar to what Mary was just saying, that the core of the network here, I don't want to argue in any sense that UCSD is not incredibly important to the biotechnology industry, along with Salk, Scripps, Stanford, Burnham, the rest of them. But in San Francisco, you have a very strong sort of spillover in technology to companies through active collaboration of world-leading, state-of-the-art, incredibly important science taking place within the labs of early companies like Genentech in connection with labs at UCSF and other places like Berkeley. You don't see that here in San Diego, and instead, the core networks are more entrepreneurial. It's people coming from industry that pull in technology from various labs around UCSD, use it for sure as the founding idea for these companies, and they also recruit lots of people from the labs and so forth. So the labor market is crucial coming out of UCSD. But the technology strategy of these companies isn't so strongly based on linking themselves either to the reputation of the universities or discoveries that come from ongoing collaboration with universities. And I want to show this briefly in two parts. Very briefly, it's just sort of a greenfield site, just like Mary was saying with wireless. A key interesting thing in these network theories is where does sort of a backbone, kind of the vertebrae, where does the backbone of these networks come from? So what I've tried to look at in San Diego and San Francisco is where do they get critical mass? And again, in San Diego, I think it came from very entrepreneurial networks linked to one company in San Diego that you've all probably heard of, Hybridtech. So here's a little bit about the emergence of Hybridtech. I went and got some of these pictures and then spelled all their names wrong, I found out. So Martin fixed them for me, which is nice of him. I was at my daughter's choir practice doing this last night. I figured he needed some pictures, so I went and found those. There's Kohler and Milstein. So Kohler is quite the handsome Nobel Prize winner there back in the 70s. I was impressed by that. Compared to the usual sort of geeky scientists, look like the rest of us. These guys came up with a really, really crucially important technology advancement, which was the creation of monoclonal antibodies. These are antibodies that could be created through cell lines, and they're essentially immortal. So they can be reproduced and reproduced and reproduced. And monoclonal antibodies are very strongly associated with as antibodies through preventing or curing disease. So it's a big part of the industry today. Some of the biggest technologies and some of the biggest medicines on the market today actually came out of this cluster, monoclonal antibodies like Rituxan, for example, or out of San Francisco, drugs like Avastin are monoclonal antibodies. That's the leading cancer drug at the moment for colorectal cancer. So these guys came up with this at the University of Cambridge. They didn't patent the technology, but it turned out it was very, very hard to reproduce it. They wrote a Nature article that described it. But basically, if you didn't have access to these cell lines and have really clever technicians, you weren't going anywhere with this technology. So what had happened is this guy who's very well known around here, Ivor Royston, kind of the scientific founder of the industry here, was a postdoc at Stanford working for a scientist there named Herzenberg that had access to these technologies through a sabbatical he did at Cambridge. So Royston started working on this, and his lifelong passion has always been cancer research using monoclonal antibodies. He came down, he was an assistant professor at UCSD in the mid-70s, and the mid to late 70s, and right away he got interested in starting a company. So he was a very clever person. He contacted the same venture capitalists that funded Genentech, and he got a company going. And in the paper, in the book, we go through this in a lot more detail. What happened, though, is very early on, Brooks Byers, who is one of the deans of venture capital investment in California, brought on a guy named Ted Green. And I think I have his picture here. Ted Green, you can tell who the managers are in this. the two people wearing ties. So this is a very early picture of Hybridtech, and green is the guy with the mustache with the tie, and right behind him is Berndorf. That's right, I got it backwards. That's right, there you go. You're right, there you go. I'm just testing to make sure you're paying attention here. And anyway, they're the founders of Genentech. Green came from an industry background. If you've read Monica Higgins' books on the Baxter boys, he was one of these boys basically that came from industry and kind of had a product manager, commercialization. He had taken products from bench to bedside, and he brought that to Hybridtech, and that's been their motto. Okay, I'm gonna finish up in a second here. So what happened? This became a big company. It was the dominant company here. And a very similar parallel, again, to link a bit, the company ended up being acquired by Lilly. After the acquisition, almost everybody in the company left. They had a very strong social network to one another, and they ended up forming the rest of the biotech cluster. So here are some slides. I won't go through these, but you can see Hybridtech is red, and you can see kind of that network backbone forming as other companies were created after this acquisition, which was in 1986. And by 1989, 1990, you have this big network forming out of that. Here's one of these same beginning charts and it actually comes from UCSD Connect, showing some of these early companies that came out of there. So I'm not going to go through this in a lot of detail today because I need to wrap up, but what's really interesting is looking at the cliques of individuals within Hybridtech that started a bunch of these companies. And if you look at it really closely and read into the literature here, there's a clique around the venture capitalists and there's a clique around the Baxter people. And there are these two wings of companies that got going out of this. And I'm not going to go through this in any detail. So to wrap up, what are the implications? And this is where I'm coming from some of the stuff from the book. The interesting thing is that this early technology strategy of Hybridtech, which was imprinted on these various alums, really influenced the characteristics of the cluster here and how companies in that cluster have interacted with UCSD and other organizations here like Salk and Scripps ever since. There are differences and variations, but there's a lot here. If you look at publications, so this is all stuff from the book now, so this is the newer data I got. Red is San Francisco and blue is San Diego, especially if you look early on, the first, the 80s and the 90s. Yeah, but especially you see this big jump. There are big differences in how companies engage academia in these clusters. And this is sort of the stuff we're trying to talk about here. Big differences here. I won't go through a lot of this, but this is from San Francisco. If you look at the number of papers in Nature or Science, that last column, coming out of prominent companies in San Francisco, what you can see is that a really important part of the strategy of these companies was creating a reputation of being sort of scientific powerhouses through publishing in these journals. So if you look at Genentech, they had 65 publications in Science and Nature, about 70,000 forward citations and so forth. And this is common through a lot of these companies that tend to have links to Genentech. These are early companies in San Francisco. If you look here at San Diego, and there are some differences. It's not like every company avoids science. There are some that don't. But if you look at Hybridtech, they had, in the same tape, this is the early 80s time period, they had one article in Nature or Science. And far fewer publications. Most of their publications, I went through and looked at a lot of them, are validating clinical trials for their diagnostics to try to get doctors to use them. So you see this just really different kind of imprinting in how companies engage the local universities. And that's one of the things I talk a lot about in the book. There's some more data, we'll go through this. Just to finish up, I've also got some data on number of inventors in the region, which is also, I find fascinating because San Diego is incredibly successful as a cluster. But if you look at just number of scientists doing inventions, it's just separate patents, it's much more closer to LA than it is San Francisco. So there are size effects here too, but I was really surprised by this data. I've got some other, these are inventor networks from patents. So this again is San Francisco. It's really hard to see this without really going into detail, but there are big splotches of blue, which is biotech, and there are red, which is academic patents. What you see is a lot of people, a lot of biotech companies closely linked to academics. So here's the San Diego network, and a network has developed here. It's not nearly as dense. This is data from about 8 or 9, 10 years ago. What you see here, and it's hard to pull out, look at this big cluster here. You have biotech clusters of patents, then you have university clusters of patents like there or there, and they're not as intermingled, basically. And that, again, gets to this core point that there are two almost different communities. They have a transactional relationship for sure. They know each other, but they're not intricately involved in the science. on that collaborative basis the way you see in San Francisco. There's one more way to show this. This is the number of people that have published a patent as a university scientist and as an industry scientist in each region. And you see again that Los Angeles and San Diego look far more similar than San Francisco, where you have a whole lot more of these sort of linked inventors that are active and patented at the university and then go to industry and patent. Far less of this down here, which is just, again, really interesting as a discovery. So just very briefly, I don't want to say that UCSD is not important here. Again, the founding idea for the majority of these companies around here come from these universities. So the labor market, this is the labor market for these universities. The scientists come from this labor market. But the way that companies are the way that the university is embedded in the industry thing has differed historically quite substantially. So I go through some more of that here. One thing that I just find interesting, I've been looking at more recently, I've been doing interviews the last year on another project looking at industry-university relationships, is that I think partly as a heritage of this, if you talk to, I've talked to quite a few senior administrators around UCSD, and what I hear a lot is they have a very transactional approach to thinking about university-industry relationships. So it's been phrased to me as a kind of pay-to-play type arrangement. You don't see that at UCSF. At UCSF, it's let's get them in the lab collaborating and we'll work out the IP later. Is sort of the attitude. And I think that's one of the implications that comes from this. So again, sorry for going so fast. I've got a couple papers on this stuff. If you want them, I'd love to send them to you. And the last part is all in this book with Martin and Mary, and I'm looking forward to comments. So thanks again.
Questions of Steve? If not, we'll do a panel.
Luc de Klerk. I work for the UC San Diego Library. I'm actually a manager of the San Diego Technology Archive.
Oh, I've read through your archive.
But you didn't say very much about industry association and their role in social networking. Organizations like Connect and ComNexus and Biocom, very strong organizations here in San Diego. I don't know about San Francisco. I wondered whether they play a role as well.
The associations here are far stronger than in San Francisco. Bay Biotech is a weak shadow of what you have here with both Biocon and before that, and I think most crucially UCSD Connect.
Can I respond to that? What I've learned because I've written about all these intermediary groups. You need them more here. Mm-hmm. You see, they're more necessary because what Steve's work shows is the embeddedness of academic scientists in the industry clusters that have emerged in the Bay Area, whereas the separation here requires intermediaries. Does that make sense? Mm-hmm.
Woody Powell did some work on the venture capitalists in both of these regions. And I think the venture capitalists were the connectors in the Bay Area because, they started Genentech, really.
Yeah.
And you didn't have venture capitalists here at that time. You still have a weak venture capital community compared to the Bay Area. So I think what Mary's saying is you needed it because you didn't have those intermediaries that were already there. Because in the Bay Area, they come out of IT, right? They were already doing IT. They were already connected up. And you didn't have that intermediary. So it was a little bit more of a tabula rasa here.
Right. I know
maybe I'll sit next to Mary. Maybe we should
all sit together. Yeah. But the other thing, having been one of the founders of Connect, what's the first thing these organizations focused on? Venture capital, right? Bringing more capital to the region, and more legal and marketing competence to the region, all of which I think you had more of in the Valley just because it was earlier, that's all. And at any rate, okay. Other questions or comments, and I'll come up there.
So we have a person who's been working here at UCSD for a year and a half, 2 years, Terry Melez, who came out of UCSF, and her job was to build strategic partnerships between industry and primarily, obviously, the researchers. So given what you've described about the environment in the Bay Area for the biotech, I'm wondering if people like Terry, who maybe come out of the Bay Area, can help bring some of that culture and motivation to an environment that operates very differently historically.
Yeah, I think both UCSD and UC San Francisco these are some of the leading molecular biology departments and translational research departments in the world. And what I learned through working on this project is that excellence, not just in basic research, but also translational research that links in the clinic, has been very early here, and that really helped getting going with the industry. So you have the starting blocks for sure. It's just how do you think about that relationship going forward, and what's the model of the university? So and this is a little different from what I talked about in the paper. What I think has happened here is you have this more entrepreneurial, network-based, pull-based thing. You also have a very strong history in the region, especially through Scripps, of companies coming in and paying literally hundreds of millions of dollars for access to science. And I think that kind of philosophy and that demonstration effect has impacted how administrators here at UCSD view the relationship with science. So again, it's very pay-to-play type of thing. So you have big initiatives on campus right now. That one of the biggest ones is the Center for Therapeutic Innovation through Pfizer. And there is a very similar office here and at UCSF. So that's one of the things I'm doing is comparing these cases. And again, just the philosophy of how these partnerships are engaged. There's more of a groundswell at UCSF. It's sort of, that's at the ground level. So both places have hired people from universities, people from industry to manage these relationships. And they're both very tactical. The UCSF people spend just as much time as the people here on making sure that their professors know how to engage industry so they don't get ripped off, basically. But the willingness to sort of pitch in at the scientific, let's try to figure out how to get experiments to work to make this thing work. You just see more of that as sort of the natural way things work up at UCSF than I've seen here. Also, the project is a bit newer here, so that might change. But I think it's this very transactional, on the ground, how do we see professors working with industry, and does that need to be a contractually guided relationship or not, basically? Do the contracts come later? So, for example, UCSD has been resistant on, they did sign it originally, but it took them a long time to sign a relationship with the GNF, the Novartis GNF just down the street, and Scripps still hasn't signed one with them. UCSF signed with them right away, and it just basically lets professors play along as much as they want. And if they discover something, you do the IP. Here, the attitude is, why don't you pay us for letting us professors play with you, and then we'll also sort out the IP. So there's just a different, it's really interesting to see if this new person will help change that, though. But I think it's really at the ground level in terms of how the university sees its professors and its other PIs as working with industry, and how industry views it as well.
This again might go back to IT. I mean, the Bay Area's, IT was what created, I mean, it's Kleiner and Perkins. Kleiner and Perkins is not a biotech, it was an IT venture capitalist. In IT, patents and those sorts of things flowed much more freely. I mean, there's a chapter on UC Berkeley, and the software coming out of UC Berkeley was just, they released it. Right? I mean, even when UCOP and Tech wanted to license patents, the professor said, no, we'll just release it. And they would release it, and then it's too late to patent. So there may be, going back to the IT background, biotech in the Bay Area it was originally conceptualized by IT people, the venture capitalists who funded it. And Swanson comes out of Kleiner Perkins really prior to biotech. So maybe that's
what supports that too? I'd have to go back and check, but I don't think Qualcomm ever took venture capital. So the experiences with venture capital here started with life sciences. It's a very different kind of transactional relationship. And that's interesting. That's something we should sort of look at and think about.
If you talk to somebody, I mean, I haven't talked to nearly as many as these two have, but the way they like to phrase it is San Diego was a colony of the San Francisco venture capital industry. It was just a colony, and they gained independence. You gained independence, lucky you. But then the real indigenous venture capitalists are these same people we're talking about. So Royston became a venture capitalist. Wolliger and Green became venture capitalists.
So the VCs here are more biotech than they are IT.
Biotech guys.
Yeah, they're biotech guys, and they took what they learned from that industry and which was mostly very, very commercial product based. These companies, they had products. Very few of them early on in San Diego were the classical, it's going to take us 12 years to come up with something, so let's do a bunch of kind of reputational things like let's publicize our ability to do science, which is, a classical kind of, the big part of the playbook in biotech to this day. There is some of that here, like Agaron's a good example. They did structure-based design, and they created one of the first HIV/AIDS drugs. That's one of the examples. Ligand's another one out of Salk. But most of them had, they came out of diagnostics, or they came into parts of the industry where the 10-year horizon wasn't as apparent. And even the companies that were doing drugs, so IDEC was one of the big ones, and that was founded by the same team that founded Hypertech. They, again, didn't have this academic approach. They were able to get a lot of resources through their kind of entrepreneurial networks and their reputation from founding Hypertech. The best example of this is actually Amylin, which is Ted Green's next firm. This company, there's a case study. If you're a business school professor, there's a great case study on them. And why this firm didn't fail 15 times in its first 15 years is a testament to their doggedness in getting capital after capital after capital. Or it's all business development and cash raising. And it took them 15, 20 years to get a product to work. But their strategy from the beginning, the technology came from a New Zealander working at the University of Oxford. And it just has never been a company really strongly embedded into the science part of the cluster. It was mostly a business development play until they got something to work. And then a couple of years ago, they got bought out by BMS. That's a good example.
I do have one more question for you, Steven.
Okay.
So what's LA's problem?
It's so complicated.
Martin and I have talked a lot about this.
Yeah, I'd love to hear what's your
I
theory?
have a simple-minded.
Yeah, there's the traffic issues.
It's one of the largest dispersed cities in America, and Caltech. I mean, I made casual reference to land use, but the agglomeration effects around Stanford and the Torrey Pines Mesa agglomeration effects contrast vividly with the development of LA. UCLA's on the west side, USC is downtown, and Caltech is on the east side.
And Amgen's up in Ventura County.
Yeah, I mean, and so there aren't the relationships. And Steve has also pointed out to me that the decision to locate the Irvine campus, for example, in the southwest corner of Orange County, positioned it many miles away from the medical device industry that had already incubated in the northwest corner of Orange County. Whereas here, there were deliberate land use decisions, right? To have everybody close together. Just in the Silicon Valley, I think it was more opportunistic. Here, it was a little more planned. But so these agglomeration effects, I think, have something to do with it.
That's part of it. I also think the success of San Diego in particular, and Silicon Valley, if you look at the history of startups out of Caltech, a lot of them are incubated very early on in Pasadena, and then they get venture capital money from here or San Francisco. And the first thing they're told is, there's lots of lab space that you can get at least pretty good rates up in San Francisco or San Diego. There's basically none in the Pasadena area. There's a little bit more today. So they end up moving, the labor market's there, so you have these kind of magnet effects. The part that I just find, I like it because it's closest to my own view, is the role of Amgen. Amgen, number one, it's in the middle of nowhere up there in Thousand Oaks. It's become more of an agglomeration today. But, there's a lot in Amgen, and they're one of the biggest supporters of KGI, so I've been able to speak to a lot of their managers over the years. And my favorite all time is they started a bioprocessing center where I work at Amgen. So we had this big dinner where a lot of the old guard, like 30, 40 people that were all kind of retiring gray hairs from Amgen, I went around and talked to a lot of them at this dinner, and they'd been there forever. There's very low labor market turnover at Amgen. If you read a book by Gordon Binder, the long-term CEO, he celebrates the very low labor market turnover at Amgen as one of the things he's most prideful about that company, compared to the very high. So you go to Amgen at literally 3, 4, 5% per year, compared to some of these San Francisco companies, 15, 20% a year. So people didn't leave, they stayed forever. They also had a hit fairly early on. They've been singularly unsuccessful in actually developing their own drugs after that first drug, Epogen. So, but they bought the pipeline of other companies to keep themselves going. But this company, for example, they spend $300 million on a drug called leptin, which was I needed to lose weight, a weight loss drug that failed spectacularly in any test they ever did on it. It worked really well. And if you want a mouse to lose weight, leptin is your drug. They could just spend resource after resource. So people stayed there forever. It's a very stable company. You talk to them, these people at this dinner, though, it's like, so what are you up to? It's like, well, I'm thinking about retiring because this is just when Binder left. Are you going to go to other companies? No, they did one of two things. They'd buy a Malibu beach house, or they'd buy an avocado farm up by the Reagan Ranch up there. And it's just not Genentech, where, or Hybridtech, or any of these companies. And I really think that's the senior management pool that have that downstream expertise that needs to be linked to the science. And it never flowed into the technologies coming out, especially of UCLA, but also Caltech, or more recently USC, the way you see here.
Let me pose an interesting sort of counterfactual here. The two other biotech regions have the very best universities in the United States. I mean, Harvard and MIT, UCSF, Berkeley, and Stanford. And at San Diego, very good university, but it's not in the top 4 in the United States. Maybe San Diego is the really interesting case study, and maybe it really is Hybridtech, a kind of another serendipity. And so you could make that argument. I'm not sure it's right, but it is interesting.
No, but I had another epiphany listening to you, because TSRI, the Scripps Medical Research Institution, which does about $450 million in research a year, not trivial, is the one that started very early these transactional relationships with Johnson & Johnson and Novartis. And these were private, not-for-profit research institutions. So it could have been that the culture, right, reinforced the research culture in the private not-for-profits, Salk, TSRI, what is today Sanford Burnham, could have reinforced more transactional approaches.
Because if you look at the Boston data that Woody has run, Boston is very academic-centric also. So the two academic-centric ones are Boston and the Bay Area, of the big 3. These are the global big 3, right? I mean, you're in the top 3 here. But this one is different.
Yeah, it's a really good point.
Yeah, it really is fascinating, because that slide I showed you on just Binder networks, San Diego traces exactly to Southern California on that, where you see this huge difference in San Francisco. I didn't put the Boston data out there, but
my guess is the Boston looks like
it's just like it.
Yeah.
So I really think, again, it's the interaction between the business community and the science, which developed in this interesting way here, and you've been able to reap the profits from it ever since, which is tremendous. I also just think the parallels with the CMOR was sort of fascinating. So.
So we've got to wrap up, but thank all of you for coming. Yeah, I think it was an exciting speaker.